So what you find here is the computer automatically analyses, and it'll list on the right hand side the potential mode shapes. If it's got a tick, it's got really good stabling frequency and damping. You can see the software's automatically doing that, but that's just that axis there, and then we're going to run through. So we've got frequencies here around 7, 12, 22. Ooh, that's interesting. We've got one at 46 there. That is interesting. This is where that casing vibrates. But definitely some dominant lower ones. Yeah, that one. So this one is quite close to the running speed, which is 49.8, I think. Right, so that data looks good, so I'm just going to analyse now. And what's cool with this now, it's put the frequencies in this left-hand column. We can actually view, if I'll just brighten up the image a bit, you can actually view the raw impact. So you see, that's what you see with your eye. Didn't see anything there because we've not amplified. Let's bring it back. Let's add a bit of amplification, not too much. Remember, this is the raw data. Here we go, hammer going in. Boom. Ooh, look at the floor. That is crazy. Oh, there's definitely a long one there ringing out. Okay, so this is absolutely amazing now. We can actually pick an individual frequency, and it'll automatically crop and filter to that frequency now, so the quality is going to go up, and then we can basically just visualize. This is 7.9 hertz. Let's increase the amplification a bit. Yeah, look at that rocking. This is not a good stable machine. Okay, let's look at 12.8 hertz. These are the different mode shapes off the machine. And remember, this is not running. Oh, look at that. So they're sort of going in and out of phase with each other at that frequency. That was really quite cool. 22 hertz, let's have a look at that one. I'm just going to increase amplification on that. I think that's a bit lower. Oh, that's like a side-to-side motion. That's interesting. Basically, these are not really bolted properly to the floor, which is causing a lot of these frequencies. 29 hertz, let's have a look at that. Can't see so much in there, I'll just increase the amplification. Okay. And then this is an interesting one on the casing. Let's have a look. Oh yeah, I can just see. Do you know what I think I'm going to have to do here is get a bit closer, put a 25mm lens on, because it's a higher frequency. I can see sort of some separation, some rocking there on that casing. This is where we've been getting some higher vibration. Okay, that's really interesting. So what's also cool, if say we pick from here, I can tick which ones I want, and then I can see the waveform data, spectral data. So just like you would with a normal modal hammer and analyzer. FRF, really key, frequency response, which has got these natural frequencies. And then quite a cool one, coherence. And then again the phase. I'm not going to go through every measurement point here. But you can see when we get into these resonances, you're getting a phase shift there, and we can look at the data. So after the initial modal testing, I wanted to try and bump some different areas on the fan just to check the frequencies. So I did some testing on the actual base, on the gantry floor, but none of the frequencies were close to the running speed. Again, I did some on the fan casing, and again, no frequencies near the running speed. So then I focused back onto the actual volute where the motion we'd seen in the MA and the previous modal test, and did some more detailed bump testing there. And we actually got, you can see here, we got some nice flexing of that casing, sort of top to bottom. And this frequency was around 47 Hertz, so I then changed some different angles, bumped it again, drawed some measurement points, and got a really clear response at 47.14 Hertz, which is within 20% of the fan running speed, and you can really see the rocking motion there. There's flexibility on those vertical supports. There's the actual running data, and you can see that same motion is present due to a lack of stiffness. The one on the left is the modal offline, and the one on the right is the motion amplified footage. So it's quite clear from that data. So what I'm recommending on this is stiffening the vertical supports, maybe some bracing to reduce the vibration levels by increasing the natural frequency of the structure from 47 to above the rotational speed.